Hi all, this is Mr. Yeager with chemistry. We're looking at solution stoichiometry. So, as it says there is not a lot to this because we've already done lots of stoichiometry last unit. The only thing we got to keep in mind when we're doing solution stoichiometry is just get to the mole. As we said, that's what stoichiometry depends on, is the mole, because that's how we can change from one compound to the other. So focus on the mole in the molarity formula and we can go from there. So how do we kind of approach it? You're going to be given a problem. We need to get into the mole. All right, we need to get into the mole, convert molarity to moles or grams to moles, depending on what they give it to you. This is only going to be molarity. Molarity equals moles over volume, moles over liters. You're not going to see this with molality at all. So it's just the molarity formula we're going to be using quite a bit. We convert to moles, use the mole ratio to go to the desired compound, basically a one-step stoichiometric calculation. And then we go back and plug it back into a molarity calculation again. So we're going to use molarity basically twice on either side with the mole ratio in between. All right? So basically, what does this look like? So we have this problem here. H3PO4 plus 3NaOH produces Na3PO4 plus 3H2O. It's already balanced. How do I know that? It already has coefficients in the chemical reaction. So how do I approach this? All right, it's asking how much 0.2 molar H3PO4 is needed to react with 100 milliliters of 0.1 molar NaOH. Let me be clear with this. It's basically asking for the volume. Okay, it'll be much clearer when you get to quizzes and tests. How much volume do you need in order to react with 100 milliliters of 0.1 molar NaOH? Now, some people might look at this and go, wait, isn't this dilution? Read it for context. Does it say anything about diluting? Two, we can't dilute from one product to another product or one reactant to another reactant. So we are changing from one thing to another, which is why this is stoichiometry. Okay? So the approach we would take, all right, is basically we're trying to figure out the volume of H3PO4. But I know the volume and the molarity of NaOH. So I would do a molarity calculation here to figure out the number of moles. Okay? So I have 0.1 liter, 100 milliliters is 0.1, and I want to figure out the moles. So this is just 0.1 times 0.1. I'm going to do that right now. There's 0.01 moles of NaOH present. This is going to then react. We need to figure out how much moles of H3PO4 react. Well, I'm in moles of NaOH, so I can go from moles of NaOH to moles of H3PO4. So there's my stoichiometry. It's a mole-to-mole stoichiometry, 1 to 3. So how many moles of H3PO4 will I need? 0.01 divided by 3 is 0.0033333333. Okay? So 0.0033 moles, all right, of H3PO4 is how much I need. Well, it's asking for the volume, so then I go back. I do my molarity calculation again. Molarity is moles over liters. I have 0.0033 moles. This is a 0.2 molar solution. I need to find the liters. Multiply the liters out. I get x times 0.2 equals 0.0033 divided by 0.2. Sorry, I'm running out of space here. I'm going to erase this down at the bottom here. And I get divided by 0.2. And x is equal to 0.017 liters, which is basically 17 milliliters. Okay, getting me back to my 2 sig figs, essentially. 17 milliliters is what I have. So sorry I had to erase that part, but basically, 1, convert into moles, 2, mole-to-mole stoichiometry, and then 3, back to a molarity calculation again. That's how a lot of these basically will work out. All right, that's what we're working with it. All right, I have one more problem I want to show you. Let me go back to this. All right, let me go ahead and do number 1. Okay, this is probably as complicated as they could possibly get, because in this one, we do need to find the limiting reactant. This one goes, how many grams of silver chromate will precipitate when you have 150 milliliters of 0.5 molar silver nitrate added to 100 milliliters of 0.4 molar potassium chromate? So I'm trying to figure out how much silver chromate will come out. all right? But I'm given the two reactants. This is the one reactant, this is the second reactant, okay? So I need to do a limiting reactant. I need to kind of start off with that. So I'm doing some stoichiometry again. I need to convert both of these to moles. So what I would do, I'll show this all, 0.500 molar, x moles, 0.15 liters, so 0.15 times 0.5. There are 0.075 moles of silver nitrate. And I'm going to speed up on the other one a little bit. 0.4 times 0.1. There are 0.04 moles of K2cro4. Now, I know some of you might not see this, but I'm going to do it this way anyway. This equation is saying I need 2 times the amount of potassium chromate to react with it. I need 2 times the amount of, sorry, I should have said that, I said that wrong. 2 times the amount of silver nitrate to react with the 0.04 molar potassium chromate, which means I don't have enough. 2 times 0.04 is 0.08. I have 0.075. So silver nitrate is the limiting reactant. If you don't like that method, we basically could do this next step with both moles, and you can find out how many moles of potassium chromate will form. In this case, it's just asking for grams, so you could solve for grams, okay? But in the end, I would use the 0.075 moles, AgNO3, converted to moles of AgNO2, so I got 2 moles of AgNO3 to 1 mole Ag2cro4. And then I need to go to grams, so 1 mole Ag2cro4 to grams, sorry, let me get that, I have it written down already. 331.74 grams, 331.74 grams. And so I can calculate it all out. 0.075 times 331.74 divided by 2. I should get 12.4 grams in the end. 12.4 grams. Yep. Okay. So again, this one, you didn't have to go back and use the molarity calculation. It's just saying solve for mass. So we're done. We are done, we are done, we are done. All right? So in this case, what I did again was I converted both of the molarities to moles. That's what I got here. I figured out which one's the limiting reactant. And then I used that one to help me solve for the mass of silver chromate. And again, what I could do is I could start out with the 0.04 moles of K2C, the potassium chromate. And what I would find is that I would have a greater than amount than 12.4 made by this potassium chromate in the end. There would be more than present. I mean, I'll go and do that for you real quick. It would be 0.04 times 331.74. Nope, I messed up that. 0.04 times 331.74. Potassium chromate can produce 13.3 grams, which is more than 12.4, so the 12.4 is my correct answer. All right. So that's basically the process. Obviously practice a lot more with them, but those are your 2 basic setups, and we can go from there. Thank you very much.